our negative and positive rule. Okay, 3x plus 4 minus x. Okay, the same thing that we talked about in Chapter 6 we have to do here as well. Okay, we have to change all subtraction to addition. There's several reasons why we have to do that. Well, one of the main reasons it is we have to know when a term is either negative or positive. Okay, and so in this problem right here, we have 3x plus 4 minus x. So if we rewrite that problem and make an equivalent problem where we change that to addition and we do the opposite of what's behind the subtraction sign, that would be negative x. Okay? Now, that brings me back to my point that we sort of talked about yesterday. Remember, there is a 1 right there. Okay, so that's negative 1x. Okay, so as we look at this problem, all right, I want to list the coefficients. Okay, I want to list the coefficients. The coefficients in this problem is there and there. So the coefficients in this problem is 3 and negative 1. Okay? Now, the constants in the problem is the number that's by itself, which is 4. So the constants, or the constant, basically, because there's only one of them, is 4. Okay, and the last thing I want to list is the like terms. Okay, well, the terms that are the same, remember, our definition of like terms is that it has the same variables and the variables are raised to the same exponent. Okay, so the like terms in this problem is 3x and negative 1x. Okay, now understand that you could put negative x and it would be the same thing. I'm just putting the 1 there so we start getting in our mind that there's a 1 in front of that variable without a number. Okay, and so there is a part of this lesson where you're going to have to do exactly what we just did. Okay, list the coefficients, list the constants, list the like terms. So let's do another one. Very similar to that. I'll just put over here to the side. Let's go with 10 minus 4y plus 5y minus 8. Okay, so the first thing we want to list is the coefficients. Okay, now I'm going to go through and plus a negative, plus a negative. Okay, so what would the coefficients in this problem be? Derek. Okay, 4? No. Negative 4 and 5. Okay, that's why we need to change the subtraction, because that's a negative coefficient, not a positive one. Okay, so that's the coefficients. Remember, coefficients is the numbers that are in front of the variables. Okay, that's what the coefficients are. Now, the next one is our constants. What are our constants in this problem, Tristan? Yes, 10 and negative 8. Okay. Now, the next part is a little different, just simply because it just is, because of the problem. But our next one is like terms. Okay. We know that negative 4y and 5y are like terms. Okay, but there's also another pair. 10 and negative 8 are like terms. Because we said yesterday that all constants are always like terms. So we can put the two constants together. Okay, because what they're basically asking you is what of these numbers can you put together, or what of these terms can you put together? Okay, and so this whole thing right here would be the answer. Okay, a lot of information there. Okay, now I want to look at actually simplifying expressions. Okay, now that we know the parts of the expression, I want to talk about and do some simplifying of the expressions. We'll go back to an example that we did earlier, but I don't think we actually simplified this one. Okay, 14t plus 15 minus 2t. Okay, first thing, we have three terms. All right, now, so if I take this problem and I do what I'm supposed to do, that's what you have. I changed my subtraction to addition and did the opposite of a positive 2t, which is a negative 2t. Okay, now I'm going to use the commutative property. The commutative property says I can rearrange terms in an addition problem and still come up with the same answer. So that gets me 14t plus negative 2t plus 15. And all I did there was take my terms that are alike and put them right next to each other. And so I basically have 14 plus negative 2. Okay, what is 14 plus negative 2? Derek? 12. So that is 12t. Now, when you're adding these together, another common area where people make mistakes on this is they'll put 14t plus negative 2t, and they'll say they have 12t squared. Okay? Nothing happens to the t. It's like the denominator on a fraction. When you add fractions, if I add 1/5 and 2/5 together, it gives me 3/5, not 3/10 or 3/25. Okay? So I have 12t plus 15. Now, this gets back to that. I've got 12 boys, 15 girls. Okay? I can't say I got 27 girls or 27 boys. Okay? I still just have 12 boys, 15 girls. Okay? All right, so that is my simplified answer. Okay, you can't go any further. That's it. That's all you have to do. All right, let's look at another one. I want you to try this one on your own. 4k minus 10 plus 7 minus 7k. Okay, first things first, change all your subtraction to addition. All right, who has an answer? All right, Nicole? Okay, negative 3K, put it down here, plus negative 3. That plus negative what? 2? 3, okay. Now, that is correct. All right. Now, one thing we need to look at before we go any further is this right here. I'll move it up and then I'll get back to working it. Okay? Any time in your final answer that you have plus a negative, okay, that needs to change to a minus sign if it's the last thing in your answer. Okay? Now, I'm not going to count off for it, but you need to get in the habit of seeing that this information is the same thing as a minus sign. Okay? And so your actual, what they would put in the book would look like that right there. Negative 3K minus 3. But what Nicole said is an acceptable answer. Okay, you just have to understand that eventually it's not going to be. Okay, I've still got some people in algebra this year that are still doing plus and negative instead of changing it to a minus in their answer. Okay, and we don't count it wrong. We just know that it means the same thing, and we're trying to get them to a point where eventually we don't have to do that. Okay, now let's see how we got there. Okay. The first thing is this, 4K plus negative 10 plus 7 plus negative 7K. No, it's minus. Yeah. All right, now, I'm going to rearrange it where my like terms are together. Okay, these are one set of like terms. That's one set of like terms. So here I just have 4 plus negative 7. What is 4 plus negative 7? Negative 3. And I put my K with it. Here I have negative 10 plus 7, which is negative 3. And I put a plus sign there. Okay, that little plus sign just comes down. Okay, and that's how we got that answer right there. Okay, let's look at another one. 6 minus 2L minus 7 plus 3L. Okay, do that one on your own. First thing you have to do is change all subtraction to addition. All right, Erica, what'd you get? Yep. 1L plus negative 1, or you could have said this. It could have been negative 1 plus L. Either one of those are correct. Now let's look at it. Negative 1 plus 1L, that's fine. Yeah, that's the same thing. All right. If we look at it, we have 6 plus negative 2L plus negative 7 plus 3L. We use the commutative property and put our like terms together. 6 plus negative 7 plus negative 2L plus 3L. Okay, once again, those are the same, and those are the same. So I have 6 plus negative 7, which is negative 1. Bring down my plus sign. I have negative 2 plus a positive 3, which is a positive 1. Bring down my L. Okay, and then you have either one of those. Once again, the one does not have to go in front of the L. If you put it there, it's not wrong. Okay, but both of those would be the same answer because of the commutative property of addition. Now, realistically, if you were going to write this one, it really needs to be that right there. Because once again, you have that plus and negative. Okay, now let's look at a different type of problem, still simplifying, but we've got to take another step further. Okay, you have 6 times parentheses 1 minus j plus 2j. Okay? Now, here we have to use the distributive property before we can start simplifying. Okay, so the first thing I'm going to do is I'm going to change 6, 1 plus negative j plus 2j. Now I'm going to take and distribute the 6 to both things inside the parentheses. That gives me 6 times 1 plus 6 times negative j plus 2j. Well, 6 times 1 is 6. 6 times negative j, remember there's a 6 times negative j is the same thing as 6 times negative 1j. So what is 6 times negative 1? Negative 6j plus 2j. Okay, I already have my like terms together, and there's only one constant. So I just bring the constant down, I bring the addition sign down. Whoops, not another 6, that's not an addition sign. Okay, now I put negative 6 plus a positive 2 gives me what? Negative 4, and that's a j.
Wait, but I'm confused on how you turn the 6 times j into 6.
This right here? Okay. That right there is the same thing as that right there. Those two expressions are equivalent to each other. Okay? So that means I would just take and multiply 6 times 1. Now, up here we had that last problem. We'll use that last one. Up here we had negative 3k. Oops. We had negative 3k. That means 3 times. That's what that means. Okay? And so right here, that right there looks the same as that right there. So if negative 3k is negative 3 times parentheses k, then 6 times parentheses negative j has to be negative 6j for them to be the same. In other words, we're eliminating this right here, and you can't do this. I can't write it like this. In other words, I can't take the parentheses out and put the 6, in front of the negative sign. Okay, because if I had 6 times j, that would be 6j. Okay, I just took the parentheses out. That's the same exact expression. The difference here is I have the minus sign, so that has to be negative 6j. Just like if it was 4 times negative x. Okay, that would be negative 4x. Okay, and that's how you just do it. You're treating it like 3 separate parts, basically. The negative sign, the constant, or the coefficient, and then the variable. And so that's how we came up with the negative 6j. Now, back to this problem. Once again, you have plus and negative. So we really need to write this, since it's our final answer, as 6 minus 4j. We won't count it wrong if it's plus and negative. In fact, I'm sure somebody will ask me tomorrow, oh, they have plus and negative instead of minus signs. That's the same thing. Yes, it is. Okay, so hopefully we won't get that question tomorrow, but I'm sure we will, because all of you will sleep between now and then, and Laney's alarm will not go off, and and so. All right, so next one. I want you to try this one on your own. It's got some distributive property in it. 5 times z plus 8 minus, z plus 2 minus 8. Anybody have an answer besides just 2 so far? So I don't want to give away the answer if you're still working on it. All right. Let's see, Derek, what'd you get?
I got 5z plus 2.
That is correct. 5z plus 2. Now, let's look at how we've got that. First of all, we have 5 times z plus 2 in parentheses. Change that to addition. Do the opposite of 8, which is negative 8. Okay, then we have to distribute the 5 to both things inside the parentheses. So that's 5 times z plus 5 times 2 plus negative 8. That is 5z plus 10 plus negative 8. The only common terms that we have are the two constants. And that gives us 10 plus negative 8 would be what? 2. So it gives me 5z plus 2. And that is how we got the answer. Okay? Now, let's look at a little harder one. 2 times 2t plus 5 plus negative, minus 2t plus 8t. Okay, so we have plus a negative. So we have to distribute the 2 to everything inside the parentheses. So that gives me 2 times 2t plus 2 times 5 plus 2 times negative 2t plus 8t. Since I distributed the 2 to everything, that gets rid of the parentheses as far as the big parentheses. Okay, now that gives me 4t plus 10 plus negative 4t plus 8t. My common terms are those. So I'm going to use the commutative property, put 4t plus negative 4t plus 8t plus 10. Well, what is negative 4 and positive 4? 0. So that's 0t plus 8t plus 10. What is 0 plus 8? 8. So that would be 8t plus 10. Those are not the same, so I have to stop there. All right, last one I want to look at. 5a plus 2, minus 2 plus b minus 3b plus 2a. Okay, so we have plus negative plus negative. Now, we have 5a and 2a that are the like terms. We have b and negative 3b that are the same. And then you have your constant that doesn't have any like terms. So, that would give me 5a plus 2a plus b plus negative 3b plus negative 2. Now, understand that you can't use the commutative property unless you've changed all subtraction to addition. Okay, you can't rearrange the terms unless it's all been changed to addition. Now, 5a plus 2a is what? 7a. Plus b plus negative 3b. What? Negative 2b. Okay? Plus negative 2. Now, once again, plus a negative, plus a negative. So we need to write it as 7a minus 2b minus 2. Remember, this is okay but we really need to go to there. Do what? Okay. B plus negative 3b. Here's what we have. Here's the way to look at it. Like we talked about yesterday, this is B plus a negative B plus a negative B plus a negative B. Okay? A positive and a negative are going to cancel each other out. And so that leaves me with 2 negative 2b's. Just like 2a and 5a. Okay, if we look at that one again, if we have 2a plus 5a, what that is a plus a plus a and so I have 1, 2, 3, 4, 5, 6, 7, and that's how we get the 7a. Okay? All right, your homework. And please, don't put it off tonight and go, oh, it's going to ice and stuff. We won't have school tomorrow, so, and then it doesn't do what the weathermen, Remember, the weathermen are the only people that can be 20% of the time right and still keep their jobs. Okay? You can imagine if I was a teacher and I got as much wrong as the weathermen did, your parents would probably be very hacked that they're spending their money me teaching you math and saying 2 plus 2 is 5 one day and 2 plus 2 is 4 the next day. Okay? So if you want to be wrong, be either a professional athlete or weatherman, and you can make a lot of money being wrong most of the time. All right. We got 1. We have 7.2, 1 through 27, of which we did, I hazard a guess at maybe half of them. Now, hang on, I forgot to do one other one. Let me give you one example here. This is a rectangle one. You have a rectangle, and one side is z plus 1, one side is 3z. And they want to know the perimeter. Okay, for the perimeter of a rectangle is you add up all the sides, correct? Yes. Okay, so if this side here is 2z plus 1, then that has to be z plus 1. This would have to be 3z. So we'd say 3z plus z plus 1 plus 3z plus z plus 1. Okay, my like terms are those and those two. So I have 3z and 1z, you get what? 4z. A 4z. Instead of a 1z, you have a 4z. Then you have a 3z and a 1z there, and it gives you 4z plus 2. Okay, now I have 4z plus 4z gives me 8z plus 2. And that's your perimeter. That is the expression you would need to have to get the perimeter. Yeah. All right, so get to work. Still got about 10 minutes left in class.